Hey grade 9s, today we are going to do the last lesson of this unit. We are going to try to take line symmetry and rotational symmetry and apply them to one scenario. In other words, what we're trying to do here today is we're trying to identify what types of symmetry exist on the Cartesian plane, looking at does line symmetry, does rotational symmetry. Can we see either of them? Can we see both of them? Or maybe we'll see situations where none of the above applies. All right. So right here, we have a situation where we have a rectangle A and a rectangle B, and we see that we have a red dotted line here. That would indicate line symmetry. So line symmetry exists through 1 on the x-axis. And by drawing this line here, we also see that at point K, which has the coordinates 1, 2, there's rotational symmetry of 180 degrees. If we take A or B and rotate them 180 degrees about that point K, they will coincide with the other rectangle. So this particular situation has both rotational and line symmetry. Okay? All right. And again, just like I mentioned a second ago, you may have a situation where there is no symmetry, where there is just line symmetry, where there's just rotational symmetry, or where both line and rotational symmetry exists. Your scenario could be any of those 4, okay? Any of those 4 are possible. All right. So, with that in mind, let's move on. Let's do some examples. So here we have, is there line symmetry or rotational symmetry with these 2 rectangles? Well, just like the last situation, what we're going to actually be able to do here is we are going to be able to draw a line, and that line that we're going to draw is right here. That line is where there is line symmetry, because each of those rectangles is 3 units away from that line. So there is line symmetry there. So let's write that down. That would be -2 on the y-axis. That's where that line lives. So there's line symmetry through -2 on the y-axis. We also have to look at where there is rotational symmetry. And this point right here will represent where that rotational symmetry is going to live. So that point is the point -3.5 and -2. So there's also there's rotational symmetry about -3.5 and -2. So it exists there. Okay. So this particular situation has both line symmetry and rotational symmetry. And we'll move on to the next one. Is there line symmetry here? No, there would not be line symmetry. Actually, wait a second, wait a second, wait a second, wait a second, wait a second. Yes, there would be line symmetry. I lied. Where's the line symmetry? The line symmetry would be that's a line. And that's a line. Two lines. Two examples of what line symmetry is. So, we'll write that up. There's two lines, so we have to talk about both of them. The first one went through -1 on the y-axis. The second one went through 4 on the x-axis. Now, where those lines met is actually the center of the shape. And that's actually where we'll have some rotational symmetry as well. So there'll be rotational symmetry about that point. That point is 4, -1. And what's it going to be? Well, what we can kind of see is it's actually going to be 90 degrees. It's every 90 degrees, that shape is going to coincide on itself. So therefore, it has 90-degree rotational symmetry. And if we were going to go there, we would say that the order of symmetry, order of rotational symmetry, that is, would be 4 because 360 divided by 90 is 4. So there's 90-degree rotational symmetry, or we could say the order of rotation is 4. Okay? Here we're given a rectangle and we are asked to rotate it and then see if there's any type of symmetry that results. So, if we rotated 180 degrees about the origin, what would that look like? That's what we would get. And this would be our B prime. This would be our A prime. So that would be our C prime. Now, symmetry. Is there line symmetry here? I don't think so. No, no line symmetry. So we would say no line symmetry, but there would be 180 degrees rotational symmetry. If you rotated this object 180 degrees, it would coincide with itself. So no line symmetry, but there is rotational symmetry. Now, next one. What if we translate this 6 units left? That means every part of the diagram goes 6 units left. Okay? So, there's 1, There's one. There's one. There's one. Okay. A prime, B prime, D prime, C prime. Is there line symmetry? And yes, there is. The line symmetry that exists will be right here. So there's line symmetry through negative 1.5 on the x-axis. How about rotational symmetry? Well, that would be the middle of that, but that'd be the middle point there. So we could have line symmetry. So we could have 180 degrees rotational symmetry about that point. Negative 1.5 and 3. So this scenario has both types of symmetry. There's line symmetry. It's through the line that crosses through negative 1.5 on the x-axis. And there is rotational symmetry too, 180 degree rotational symmetry. Okay. And we'll move on to more examples. In fact, there's just one more. Draw the pentagon after the translation, write 4 down 2, label the vertices of the image. Does the diagram have symmetry? Okay, write 4 down 2. Okay, is there symmetry here? Well, there's no line that we can draw that's going to allow us to reflect either of these shapes over onto the other. So there's no line symmetry. And there's actually no rotational symmetry here either. There's no symmetry at all. So we would just say no rotational symmetry, no line symmetry. So no line symmetry. And no rotational symmetry. So there's no symmetry of any type here. And we can kind of, once you do enough of these questions, what you're going to be able to do is you're going to be able to look at it. You're going to be able to say, okay, yeah, I see symmetry here. Or, yeah, no, I don't see symmetry here. And most times you're going to be right. And in this case, there is no symmetry. So that's all there is to it. The practice questions are on the screen. Make sure to go through these. Make sure to look and see if there's symmetry in each of the different questions presented. And also make sure that if you're not sure, ask for help.